All right, we're going to jump into section 4.3, exponential functions. We'll start it today in the video and then finish 4.3 in class. So our learning targets, the first one, be able to evaluate exponential functions, be able to graph an exponential function using the table, and then being able to find the equation of an exponential function using the transformations of the graph. So please make sure you have those learning targets written down in your notes. Okay, so this is a quick review of the laws of exponents. This you learn in Algebra 1 and also used in Algebra 2. So I'm just going to go through it really quickly. You please make sure you have all 6 of these written down, because when we're practicing and doing stuff in class, if you don't remember them, I will tell you, take out your notes, take a look at them. Okay, because this is review, this is something that you should know, should have memorized. So please make sure that these are written down so we can refer back to them later. So the first one, we have multiplication. So if you multiply 2 numbers together that have the same base, then you are adding their exponents. The second one here, we have a number that is raised to a power and then raised to a power again. So if you have one number, one base, and a power raised to a power, you are going to multiply those powers together. So a to the s to the t is equal to a to the s times t. So we multiplied those together. Third one, we have 2 numbers with different bases being multiplied together and then raised to that power. So you can split that up and have each of those separate numbers raised to that same power. Anything raised to a 0 power is always equal to 1. If you have a number raised to a negative exponent, that means we are finding the inverse. We're inverting it. So a to the negative s is the same thing as 1 over a to the s. And lastly, if I have the other way around, if it's 1 over a to the negative s, then we invert it so that it's a to the s. Okay? Essentially, that is a to the s over 1. So we just flipped that fraction. So anytime you have a negative, whether it's in the numerator or the denominator, you're flipping the fraction and then the exponent becomes positive. Okay, so again, review those exponents, write them down, make sure you know them. If you have any questions about any of those, jot it down, let me know in class. Otherwise, we're going to move on. All right, exponential functions. An exponential function is in the form f of x equals b to the x, where b is a positive real number. So in other words, b is anything greater than 0 and is not equal to 1. Okay, so anything that is greater than 0 but not equal to 1. So from 0 to 1 and from 1 to infinity but not equal to 1. And the reason why we exclude 1 is because if I had anything, 1 raised to anything is always just going to be 1. Okay? And if I have the function f of x equals 1, that's just going to be a straight line at y equals 1. So that is not going to be an exponential function. That's just a straight line. So 1 raised to any power is always just going to be 1, so we exclude that from our exponential functions. All right, so let's talk about graphing an exponential function. We're going to look at the couple of graphs of exponential functions, 2 different types or 2 different examples of exponential functions, and then talk about the properties of those functions. So if I have f of x equals 2 raised to the x, and I want to graph it, we can just graph it. We can make a table, pick some points, and plot them just like any other graph. So because I'm not so sure about what the shape of this graph is going to look like, I'm going to go with my default standard x values that I always use when I'm working with a parent function, a function that hasn't been transformed yet or anything like that. So usually I just start with -2, -1, 0, 1, and 2. That gives you a nice round. You have a couple of negatives, you have a couple of positives, and you have 0, so you can get a good idea of what the shape of the graph is going to look like. So what I'm going to do is I'm going to take 2 and raise it to the -2nd power. And remember, we just talked about that this is going to be, we're going to invert it whenever we have a negative exponent. That means to invert it, to flip the fraction. So that's actually going to be 1 over 2 squared, which is 1/4. Then I have -1, so 2 to the -1 is 1 over 2 to the 1st, so 1/2. 2 to the 0th power, we just talked about that law, that anything raised to the 0th power is always going to be 1. 2 to the 1st is 2, and 2 squared is 4. So just plugging in those x values into my x in my function. So let's go ahead and plot those points. -2 and +1/4, -1 and +1/2, 0, 1, 1, 2, and 2, 4. Okay, so we can go ahead and graph that. So there's the graph of your f of x equals 2 to the x. All right, let's look at a different example. Okay, so here's another example, f of x equals 5 to the x. And we're going to come back and talk about that in just a second. Let's look at a graph where we have f of x is equal to 1/2 raised to the x. So we're going to do the same thing. We're going to plug in some points into my x and kind of get an idea of what the shape of the graph is. So I'm going to stick with -2, -1, 0, 1, and 2. So I have 1/2 raised to the -2. And again, that negative means we're going to invert the fraction. So I invert that, 1 over 2 becomes 2 over 1, and my exponent becomes positive. So 2 squared is 4. 1/2 to the -1. Again, I invert that fraction, so 1 over 2 becomes 2 over 1 raised to the 1st power. 1/2 to the 0. Anything raised to the 0th power is 1. 1/2 raised to the 1st power is just 1/2. And 1/2 squared is 1/4. So we have -2, +4, -1, 2, there's our graph. All right, and there's another example. We have f of x equals 1/5 raised to the x. So these two graphs on the left, f of x equals 2 to the x and f of x equals 5 to the x. Both of those, the base is greater than 1. So in this case, we used a base that was greater than 1. 2 is greater than 1, 5 is greater than 1. Okay. In the graphs on the right, both of our b values were between they were between 0 and 1. So they're fractions. 1/2 is less than 1, but it's also greater than 0. 1/5 is less than 1, but it's also greater than 0. So we have two cases that we're looking at. We're looking at b values that are greater than 1, so 2, 3, 4, 5, 8 over 3, 6.2, anything like that, anything that's greater than 1. We're also looking at our second case, are b values that are between 0 and 1. So 1/2, 1/5, 1/3, 2/3, 0.67, okay, 0.3. Okay, all of those are base values that are between 0 and 1. So kind of look at these two graphs a little bit, the differences and the similarities between them. And we're going to talk a little bit about the properties of these graphs. What do you notice about them? Okay. How are they different? How are they the same? So why don't you go ahead and really quick jot down a couple of ideas. What do you notice about these two graphs? What similarities do you notice? What differences do you notice? What is similar between the 2 to the x and the 5 to the x? What is similar between the 1/2 to the x and the 1/5 to the x? What changes between those two? Then look at the graphs on the left and the graphs on the right and compare those. What changes? What's different? What's the same? Go ahead and jot a couple of those down, and I will ask you to share them in class next time. All right, if you're still jotting stuff down, that's fine. You can go ahead and you can pause the video and keep jotting some things down or looking at these two graphs to see how they're similar and different. Let's talk about some properties. All right, so we have on the left over here, I have f of x is b to the x where b is greater than 1. And over here I have the properties where b was between 0 and 1. So whenever there's just the full, some properties they share and some properties is just one or the other. All right, so domain and range. What do we notice about the domain and the range of these functions? So look at the graphs that you graphed when we did the last slide. And you'll notice that the domain, the x values in all of those graphs go from -infinity to infinity. It's all real numbers, either side. From negative to, there is no breaks in the graph, there's no vertical asymptotes, nothing like that. So the domain for both of these is from -infinity to infinity. The range, all of these graphs, there was a horizontal asymptote at y = 0. Did not ever cross over the x-axis. So the range is from 0 to infinity, but not equal to 0, because it never actually crosses the x-axis. The intercepts, x and y intercepts. So if you look at the graphs, and you can look at the ones that you have or the ones at the bottom of the screen there, all of them had the same y-intercepts and no x-intercepts, because again, it never crosses the x-axis. So the y-intercepts were always at 0, 1. X-intercepts, there are none, because it never crosses the x-axis. Asymptotes, the asymptotes for the b is greater than 1, we have that horizontal asymptote at y equals 0. And the same thing for the between 0 and 1, a horizontal asymptote at y equals 0. See, oops. Okay. So for forgot that I had these behind there. Let's go ahead and take those out here. So domain and range, y-intercept, none, x-intercept. So for the horizontal asymptotes, they have the same asymptote. The only difference is for the b is greater than 1, the graph follows it as x approaches negative infinity. So it follows the asymptote as it moves to the left, as the graph goes to negative infinity. And in the equation, or the function where b is between 0 and 1, the asymptote, the function follows the asymptote as it approaches positive infinity. Increasing, so the one on the left is always increasing, as well as being a one-to-one function, and the one on the right is decreasing. Okay, as you move from left to right, it's decreasing and moving from left to right. Common points that they both have. Okay, and so that you can go back at this slide here. If you look at the tables, they have some common points in there. So some common points between these two is that -1 and 1 over b is always going to be a point. This should actually be 0, 1 is always going to be the y-intercept, and always 1 comma b. Okay, so again, we'll look at how that looks here. So we have -1 and the inverse of that. So -1 and the inverse of your base, 1 over 2. Over here we have -1 and the inverse of the base. We also have 0, 1 in both of these, as well as 1 comma the base. 1 comma the base. So you will know that for these functions, those 3 points you will always have. Okay, so depending on what the base is. And lastly, we just know that the graph is smooth and continuous and has no corners or gaps. So if you know that, it's easy for you to make sure that you're graphing it correctly. So these properties are all things that are going to help us be able to graph these functions no matter what the base is. Okay, some quick tools and properties for graphing exponential functions. So please make sure that you have this table written in your notes, please. All right, the last thing that we're going to look at is we are going to try to determine the equation for each graph using transformations of a function. So we're going to start with the function y equals 5 to the x. So b to the x is considered the parent function. No matter what your b is, that's going to be your starting point. So you'll notice we have all those common points here. We have -1 and 1/5. So -1 comma the inverse of your base. We have 0, 1, and we have 1 and the base. So all of those common points that your graphs are always going to start with. So since our base is 5, we have -1 and 1/5. We have 0, 1, and we have 1 and 5. So the first graph we're going to look at, we want to look at all of those points to see how they move. Oh, the other thing you want to keep in mind is our horizontal asymptote. That starts at 0. Always at 0 for those parent functions. So if we look at number 2 here, we want to see how this moves. Well, it didn't move up and down at all because our horizontal asymptote is still at 0. So I didn't add or subtract anything to that vertically. So let's look at our common points. Our common point, -1, 1/5, now moved to 1, 1/5. Our point 0, 1 now moved to 2, 1. And then our point up here moved from 1, 5 to 3, 5. So in all of these instances, we added 2 to the x value. So the y values didn't change at all, and we added 2 to our x values. So our function is going to be y equals 5 to the x minus 2. So that is our inside function. Whenever it's with the x value, it's always opposite. So x minus 2, since we moved to the right 2. All right, let's look at number 3. So you'll notice that our horizontal asymptote moved up 1. Okay. Our x and y, so then we have this point, our -1, 1/5 is still at -1, but now we have 1 and 1/5. Our point that was at 0, 1, still at 0, but now at 2. Okay, and we can't see that other point, but I think we can see that it didn't move to the left or right at all, it only just moved up 1. So we have 5 to the x plus 1. That's on the outside of our function. So remember, when it's with the x value, it moves left or right, and when it's on the outside, it moves up or down. Okay. All right, last one that we're going to look at together. Notice our horizontal asymptote moved down 2. And then we have our point, there's -1, 1/5 point moved over here. Okay, it's changed sides. So now we have +1. Oops. Oh, eraser's not working. All right, well, my eraser's not working, but so we can see that it flipped sides. Also, our point that was at 1, +5, is now at -1. Okay, it still goes 5 up from the asymptote, okay, but it's now on the other side of the y-axis. So this was flipped. Okay, we had a reflection across the y-axis. So now we have y equals -5 to the x minus 2. So that negative on the outside flips it across the y-axis, and the -2 moves it down. Okay. So 5, 6, 7, and 8 is going to be your job to finish before coming to class. So take a look at how these graphs change from the function y equals 5 to the x. And if you need to rewind the video a little bit to kind of look at what that graph looked like again, you can do so. But try and write these 4 functions of what these graphs look like before coming to class next time.